forages were robbed of their nutrients, leaving them only as a big, heaping, compacted pile of water, lignin, waste, and dead cells, aka a poop pile. Who or what could have done this? This looks like a job for the Digestive Detective! Dun dun dun! From the evidence I have collected so far, I have narrowed down the suspects to a group of very sketchy organs. They call themselves the horse's digestive system. But I need more clues. Let's head over to the scene of the crime. The first suspect is the mouth. This convict started it all with prehension, or grasping the food with the lips. But he didn't do it alone. The teeth, tongue, and salivary glands had a part to play too. The incisors bit and tore the victim from his home. The tongue pushed the food to the back of the mouth, and the molars ground the forage into smaller, flatter bits to be swallowed. When mastication or chewing began, the salivary glands come into play. The three salivary glands are the parotid, sublingual, and submaxillary. Saliva serves as a lubricant to help food go down the hatch. Saliva also contains bicarbonate, which helps neutralize or buffer acid from the stomach. The mouth hands off the victim via deglutition or swallowing to a middleman called the pharynx. The pharynx is a 6-inch muscular tube. One part of the pharynx is the epiglottis. This flap keeps food from falling into the wrong hands, like the windpipe. Suspect number 2 is the esophagus. Peristalsis, a wave-like motion, pushes food down this 5-foot-long muscular tube. At the end of the esophagus is the cardiac sphincter. This ring-like henchman keeps the horse from burping or vomiting. Needless to say, the crime had come too far to be undone. The next suspect is the stomach. This J-shaped sac has 2 main sections. The hydrochlorogastric, gastric lipase, and pepsin are secreted from the glandular, the lower portion. Gastric lipase strips the food of fats, and pepsin digests protein. Protein aids in the formation of tissues, like muscles, and produces hormones, enzymes, and antibodies. Protein also helps maintain homeostasis. A lack of protein can cause muscle loss and weight loss. But the crime could not have gone on without hydrochloric acid. The acid mixes with the food and acidifies it so the other two may do their job. The stomach is a common place for gastric ulcers because the non-glandular upper portion was not made for the low pH levels of the gastric secretion. The crime went the smoothest when the stomach was about 75% full. After about 45 minutes, the victim passes through the caloric sphincter into our next suspect. One of our main culprits is the small intestine. This organ is called small because of its 3-inch diameter, but in fact it's 65 feet long. Most of the nutrients are absorbed here. These nutrients include calcium, fats, sulfur, potassium, and vitamin D. Calcium aids in the formation of bone and maintains homeostasis within the blood. Calcium is obtained from barley, corn, oats, and rice bran. Fats is a source of energy, and a lack of fat can cause equine metabolic syndrome. Sulfur helps produce the majority of protein and enzymes within the body. Sulfur is one of the only nutrients that is not necessary. Potassium helps maintain acid-to-base balance, and if not given the right amount, can cause kidney problems. Vitamin D helps with calcium absorption and balance. Vitamin D is obtained from the sun and sun-cured hay. Everybody knows every good criminal plan has 3 phases. For the small intestine, these 3 phases are called the duodenum, jejunum, and ileum. The first phase is called Operation Duodenum. Simple sugars and starches are digested by enzymes secreted from the lining of the duodenum. The liver secretes bile, a greenish solution, into the mix. Bile aids in digestion and neutralizes acid from the stomach. The vitamin A and vitamin C are also synthesized and stored in the liver. Vitamin C neutralizes harmful free radicals and is produced by the horse. Vitamin A helps with vision and immune responses. A lack of vitamin A could cause bone fragility, growth, effects on growth and reproduction, and night blindness. The horse was made for grazing, so bile is always flowing. There is no need for a gallbladder. But there was an accomplice spotted leaving the scene. The pancreas! It claims it only regulates glucose in the blood and secretes enzymes. I'll let you off the hook this time, pancreas, but I'll get you next time! The second phase is called the jejunum. This section of the small intestine is lined with small finger-like projections called villi that snatch up and absorb the nutrients into the bloodstream. Villi increases surface space so more can be absorbed. Protein, fats, and vitamins are just a few of the things that are snatched up by the villi. The third section is called the ileum. Using sodium bicarbonate, the ileum changes digestia into a form that the bacteria in the large intestine can digest. The foregut got the job started. Now it's time for the hindgut to finish it. The food moves through the ileocecal valve into our next suspect, the cecum. He's comma-shaped, about 4 foot long, 8 gallons. On the right side, the horse steer the flag, and he's blind. By blind, I mean a blind pouch. Food practically enters and exits in the same place. His specialty is fiber breakdown and digestion by bacterial fermentation. Most of the water and water-soluble vitamins are absorbed here. The most important nutrient stolen was the nutrient water. Water regulates bodily functions, and a lack of water can cause dehydration and colic. Vitamin E and vitamin K are also taken here. Vitamin E has important antioxidants and reduces the chance of lipid preoxidation. Vitamin E is found in orchard grass, pasture grass, timothy, fescue, and alfalfa. Vitamin K helps with blood clotting, vascular health, and bone metabolism. A lack of vitamin K can cause bone abnormalities, prolonged bleeding time, and acute kidney failure. The next suspect is called the large colon. This road map they left behind shows that this organ holds 20 gallons and is 12 feet long. The large colon had to go on a pretty interesting trip to help finish the job. The parts of the large colon are the right ventral colon, left ventral colon, left dorsal colon, right dorsal colon, and transverse colon. The large colon had one of the trickiest turns in the whole system. This turn is called the pelvic flexure. Y'all get ready because I'm about to break it down. The left ventral colon narrows down from 20 inches to 4 inches, just like that. It makes a tight hairpin turn up to the left dorsal. Needless to say, this is a common site of impaction colic. Copper and iodine are also synthesized here. Copper is required for enzymes that maintain and synthesize the elastic connective tissue and is found in corn, cane, and molasses. Iodine is necessary for the production of thyroid hormones that regulate fast cell metabolism. A lack of iodine can cause thyroid hypertrophy or goiter. The next suspect is the large colon's little brother, small colon. B complex vitamins and cobalt are fermented here. The microflora synthesize vitamin B and is found in most horse feeds. The B complex vitamins are thiamine, riboflavin, lysine, biotin, folate, pantothenic acid, vitamins B6 and B12. B complex vitamins are precursors or cofactors to enzymatic processes and help make ATP in DNA. B complex vitamins are found in cereal grains, brewer's yeast, clover, alfalfa, and corn. But the small colon's main function is the formation of fecal balls. We are so close to solving this crime. Our last suspects are the dynamic duo of rectum and anus. They act as a cleanup crew to help finish the job. A waste accumulates into the rectum, and then it is finally passed out the anus into a big heaping pile of road apples. We are so close to solving this crime. Let's go over the evidence we have collected since then. The victim was chewed in the mouth, passed down the esophagus, acidified in the stomach, absorbed in the small intestine, dried up in the cecum, tossed and turned in the large colon, balled up in the small colon, collected in the rectum, and finally passed out the anus. Now, who did it? I got it! Why didn't I see it before? It wasn't just one part of the digestive gang, it was the whole gang. Case closed. Now, excuse me, I have to go make an arrest. I hope you have enjoyed my digestive mystery as much as I have. My sources are Horse Science, the Horse Industry Handbook, UnderstandingHorseNutrition.com, and EquineNews.com. Thank you. Do you have any questions?
You talked about gastric ulcers. How do you tell if a horse has those?
The question was, I talked about gastric ulcers. How do you tell if a horse has one? The horse, you can tell will not be feeling good. You may be restless, may be looking at its stomach, may not be eating or passing feces.
On average, do you know how long it takes for feedstuffs to pass from the mouth to the anus?
The question was, how long does it take for the feedstuff to pass from the mouth to the anus? It is 2 to 3 days.
You were talking about all those different vitamins, and if you buy your feed, will those be listed on the feed sack?
The question is, I was talking about all the different nutrients, and if they would be on the feed sack. There is a nutrition label, and they should all be on there with the percentages.
Okay, so what happens if they eat hay? What do you do? How do you find out?
The question is, if they eat hay, how do you find out? There are many websites, and the Horse Industry Handbook shows that, and you can get your hay tested, so it shows what's in it.
Okay, so all hay is not the same.
The question is, all hay is not the same. No, it is not the same. There are many different nutrients in each.
In your opinion, what's the most important nutrient?
The question was, in my opinion, what is the most important nutrient? To me, the most important nutrient is water, because without water, nothing happens. It will dry up and the horse will soon die. They can only live 1 to 2 days without water.